we have a work problem. So in this, we have a cost function, a revenue, and then the profit is the revenue minus the cost. And then in this, we have uh, the cost, the revenue, and the profit in the function of x, and the function of x is the number of calculators. Right. And also we have the production is increased at the rate of 400 calculators per week. And then when the production is 6,000 calculators. So x is the number of calculators. So here we have x is equal to 6,000. And then notice we have 400 calculators. The number of calculator is x per, meaning divide, and week is a unit of time. So pretty much we can write dx over dt is 400. So it is increasing, so it's going to be positive. And that is calculators per week. I should say calculators per week. So that's what we are given. Now we just find the rate, the cost, the revenue, and then the profit. Right. First, for the cost. Now if we assume both x and c are function of t, I'll just write this. Assume everything a function of t. Cost, revenue, and profit. Assume everything is a function of t. So what we do is we take derivative with respect to t on both sides. Right. So we assume everything is function of t, and then we differentiate with respect to t. The right hand side will give us dc over dt, and then we have derivative of 90,000 plus then derivative of x, we just have 40 derivative of x with respect to t. Now 90,000 is a constant. Derivative of a constant is equal to 0. So we just have derivative of the cost with respect to t, or the rate of the cost is 40 times dx over dt. Right. Now dx over dt is 400. So we'll have dx over dt equal 40 times 400. So that will be 16,000. And it is positive. So it is increasing at the rate of 16,000. I'm sorry, dc over dt. or we just simply write cost is increasing at 16,000. Uh, that whatever the unit for the cost in here we don't have it. That could be in terms of dollars probably. Uh, right, it's increasing. The rate is about 16,000. Right, so that is the cost function. Next we have the revenue function, which is 300x minus x squared over 20. 300x minus x squared over 20. Right, yep. We can rewrite as 300x minus 1 over 20 x squared. It is easier to take the derivative that way. Right. Now we assume everything is a function of t, so we can differentiate both sides with respect to t. So d over dt d over dt of 300x minus 1 over 20 x squared. Right. So we have d r over dt is equal to d over dt of 300x and then minus 1 over 20 d over dt of x squared. Right. Now similarly to uh, the other related rate problem, we have d over dt of something square is equal to 2 times that something and derivative of that. So if we have x, that's what we have, which is 2x dx over dt. So derivative of 300 x with respect to t will be 300 dx over dt and then minus 1 over 20 and then derivative of x squared is this 2x dx over dt. Right. So simplify, we have 300 dx over dt minus x over 10. Notice that 2 and 20 cancel out. That gives us x over 10 of dx over dt. Right. Now we substitute everything we have. Dx over dt is 400. X is 6,000. We have those information and we then put into to the x over dt and then x we have 300 dx over dt 400 minus x 6,000 over 10 times the x over dt 400. So 300 times 400 is 120 thousands minus 6,000 6 wait 6,000 sorry 6,000 is x, and then we cancel, and so we have 600 times 400 is 24 to 40 100,000, and that will be negative 12,000. And it is decreasing because it is negative, so it's just decreasing. And then finally, uh, we have the profit is equal to the revenue minus the cost. Uh, we should subtract the function and take derivative, but that quite a little bit of work. All here we just need to take derivative with respect to t on both sides. And so we just have derivative of the profit with respect to time is equal to dr over dt minus dc over dt. Dr over dt is negative 120,000, and then minus dc over dt, that is 16,000. So that gives us negative 136,000, and that is decreasing. Right. So that's what we have for this problem.